All right, this is Pre-Algebra lesson 3.1, rounding and estimating. I'll tell you right now, people, this is the truth. In math, if I could teach you, if you could be a master at any one skill in math, it would be that you would be able to estimate. Every time you do any math problem, a good math student estimates. They know whether or not their answer is in the ballpark. And that's a big deal. So many times I get people who are not good at math and I give them a question like this, 12.384, times, and then it's, 8.9, right? And they come up with their answer is 1004.36 or whatever. Now, here's the deal. You might think that's dumb. I'll tell you right now, a lot of you don't do this every time, and you should, because you come up with this and you do the whole thing and you work it out and you put the decimal down there and you have 1,000 as your answer. And somebody who's good at math would instantly realize, wait a second, what is that close to? 12. What is that close to? 9 or 10, right? 12 times 9 is 108. 12 times 10 is 120. Is 1,000 anywhere near 120? No. Obviously, I've done something wrong. And you do that real quick. Do you know how long it should take you to estimate a question? It should take you 2 seconds. 2 seconds should let you know whether or not you're in the neighborhood, whether or not you are close. And you can do that real quick. I mean, if you want to do it real quick, you can say that's close to 10 and that's close to 10. And the answer will be close to 100. Do you understand what I'm saying? And you go, wait a second, this isn't anywhere near 100. How long did it take me to estimate that is between about 10 and that's about 10 and 10 times 10 is 100? It should take you about how long? 2 seconds. That's how long it should take you. You want to get to where you're doing that every single time you do any math problem whatsoever. Because if it takes you longer than 2 seconds, you know what you won't do? You won't estimate. Do you see what I'm saying? You want to make the estimating so simple that it takes you only 2 seconds to do. That way you're doing it every time you do anything. Anyway, rounding. I'll show you how to do this. This is something you've been doing since, I think, 2nd grade, maybe 3rd. And that is this. If I have, 14.862, and I say, find for me the hundredths place. Do you all know the place values here? Where's the hundredths place? Which digit is in the hundredths place?
6.
The 6, right? So we have the tens place, there's the ones place, there's the tenths place, there's the hundredths place, there's the thousandths place, right? So you should be able to figure out which one is in the hundredths place, that's the 6. If I tell you to round to the nearest hundredth, that means you're rounding to this place right here. You are rounding to here. That means that you're going to write everything up to that place, nothing after it. Okay, rounding to the nearest hundredths means that you're going to write everything up to that place, nothing after it. How do I know exactly what to do? Well, you know it's going to be 14.8 at least. And now this 6, the only 2 options for the 6 are what? It can either, what are the options for the place that I'm rounding to? It can either go up or stay the same, right? It can either go up or stay the same. How do we know which one it's going to do? What do we do to figure out what do we do to figure it out? This, nope, I don't look for 6 to see if it's above 5. That has nothing to do with it. What do I do?
You see if the 2 is less than 5?
Yeah, you go over here to the one to what's right, and you look and see, is that number 5 or more, or is it 4 or less? If it's 5 or more, what happens to the 6? It goes up to a 7. If it's 4 or less, it stays the same. It looks over, it sees the 2, it stays the same. There it is. I've now rounded that to the nearest hundredth. Make sense? Okay. Again, you should have done this for years now. I know that 3rd and 4th graders are doing this. I have one in there. What if I gave you this? What if I said 14862.94? And I said I want you to round this to the nearest 100. Now, here's the deal. Let's talk about these places. That's the ones place, then the tens, hundreds, thousands, 10,000s, tenths, hundredths. Okay, so which digit is in the hundreds place? Which one's in the hundreds place, Kyla? The 8 is, right? So you underline that baby. Now remember, we're going to write down all the numbers up to that number, and then nothing after that. Kind of. If I stopped completely, and well, first of all, let's look at this. The 8. How do I, what is the 8's options here? It can go up or stay the same, right? How do we know what to do? Where do I look, Gigi? To look to the right. The 8 looks to the 6 and goes, it's 5 or more. So then the 8 becomes a 9. It goes up, right? So then it goes 1, 4, 9. Do I stop there? And do I stop right there? No. Is 14,862 round to the nearest hundredth 149? No. If it's to the left of the decimal, then you still have to give these guys zeros. Do I go like this? No, you do not. If I ask you to round to this spot here, I want nothing after the decimal, right? Nothing goes there. But you do have to remember to put these zeros here as placeholders, right? Let me give you another one. Hold on. What about this one? What if I have 7.82? And I tell you that 7.82, hold on, 7.899, and I want you to round this to the nearest hundredth. Okay? We're going to round this to the nearest hundredth. Watch what happens. Just watch. The 9 looks over here to the right and sees that the 9 is going to become one more, right? A 10. That means that we're going to end up writing 7. This 9 becomes a 10. What happens to the 8? 9. It becomes a 9. And then what do I do now? If I'm supposed to round to the nearest hundredth, what do? I have to put a 0 here. Remember, if I tell you to round to the nearest whatever place value, you have to write it up to that place value. You have to. So then you would leave it like that. If you put 7.9 and ended it there, that's not rounded to the nearest hundredth. Does that make sense? It's not. You actually have to put that 0 there. Anyway, like I said, I know this is review. You should be able to do that just fine. Okay. Whenever you are estimating, generally you're going to estimate with decimals. That is the time that most of the time you estimate. I'm going to show you, and they're going to give you like 3 or 4 different methods by which you're going to estimate. There's rounding. There's estimating by front-end estimation, and then there's estimating by clustering. I'll tell you right now, I'm going to show you all 3 really quick. I don't care at all which method you use. Why don't I care at all which method you use? You won't end up with the same answer. You won't. If Jack uses clustering, and Lauren uses front-end, and Amy uses rounding, you'll all come up with probably a little bit of a different estimation. Why don't they'll all come up with a little bit of a different answer. Why don't I care which one you use?
Because they're all in the ballpark.
They're all in the ballpark. Estimation, why do we estimate? What's the point of estimating, Jack?
To help you know if you're in the ballpark.
Right, to help you know if your answer is in the neighborhood. So if my answer comes out to 13.94, and Jack estimates, and his estimation comes out to 12, and Kyla's estimation comes out to 14, and Lauren's estimation comes out to 13, who's correct?
All of us.
They're all correct. Because each person looks at this and goes, you know what? I estimated and I said it was going to be this, and is 13.94 pretty close to 12, 13, and 14? Yeah.
Yes.
If somebody came up with their estimation is 21, you'd go, that's too far. You didn't do something right. It's not close to 12. You see what I mean? It's not close to 13.94. And so that's the whole point. And besides, I want you to get really good at one way of estimating, because how long should estimating take you?
2 seconds.
2 seconds. If it takes you longer than 2 seconds, you won't do it. Because how often should you be estimating? Every time you do any problem anywhere in math, you should be estimating. And so if it takes you longer than 2 seconds, you won't do it. So I want you to get good at one of these. Now, I will show you. I'm just going to show you one way of doing it. One way you can do it is by rounding. If I say, okay, there's 3.8. Oh, I need to make this bigger. That's why this is not working very good. Okay. 3.8 plus 5.2. Okay. Couple of different ways to estimate here, okay? You're watching here? A couple of different ways to estimate. One is to go to round this to the nearest whole number. What is 3.8 round to the nearest whole?
4.
4. What is 4? What is 5.2 round to the nearest whole?
5.
5. 4 plus 5 is 9. That would be one way of estimating. I rounded. I just simply rounded to the nearest whole number. Agreed? You see what I'm saying? I just rounded that to the nearest whole number, 4. I rounded that to the nearest whole number, 5. 4 plus 5 is 9. I'm done. 2 seconds. Okay? Another way of doing this, now, you guys all know what the answer actually is? It is 9, right? So there's the real answer. Okay, but we estimated and it came out to 9. We got it. Fine. Another way is to use what's called front-end estimation. Front-end estimation is real simple. It's even simpler than rounding. And that is, you simply do the front. 3 plus 5. What's 3 plus 5? 8. Is 8 pretty close to the real answer, 9? Yes. So we're in good shape. I would take that answer. I front-end estimated. I just grabbed the front. Kyla?
Is this, if there's any extra, you have to add that too?
You do what you want to do. I'm telling you what I'm telling you to do. Right? Another way of doing this is to cluster. You would cluster if we had something like this. If I had 3.9 plus 5.3 plus 4.8. Clustering means this. First of all, could we do rounding on this? Let's round these. What is 3.9 close to? 4. 5.3 plus 5, 4.8, 5. 4 plus 5 plus 5 is 14. We're done. That would be estimating, right? Another way is to use front-end estimation. What is 3? This would be 3. What's 3 plus 5 plus 4? 12, right? So there's 12 is a possible answer. The other way is to cluster. Cluster means if all of my numbers are around a certain number, if you just can quickly look at it and go, all of them are near a number, what is that number? You go, okay, I've got, this is about a 4, that's a 5, that's a 4. You could say that all of them are around 4. Or you could even say they're all around 5. Does that make sense? And you go, well, then how many are there? 3. So what's 3 times 4? 12. Or even 3 times 5 is 15. So I could do a 12 or a 15. Those are all viable estimations. What is the real answer? 3.9 plus 5.3, that's 8, that's 9.2. It ends up being 14. Is 15, 12, 12, and 14 all pretty close to 14?
Yes.
Yeah. Remember, whatever is the easiest for you, or whatever is the easiest for the problem, that's what you're going to do. So for tonight's homework, if you guys, if the answer is 14.6, and I tell you to estimate, and Sheena comes up with 15, and Kyla comes up with 14, and Amy comes up with 13, and Jay comes up with 16, I'm going to take them all. Because it doesn't matter what method you use, if you estimated, you want to do whatever is the easiest, which means, when we're talking about estimating, easiest means fastest, right? You want to do whatever is the fastest way of estimating. Because this has nothing, listen, 3.9 plus 4.8 plus 5.3, there is an answer, and you're going to have to actually find the answer to this, right? So when you've already worked the whole problem, what's the point of estimating again? Why do we estimate? To see if you're in the ballpark. So do you really want to spend as much time estimating as you did working out the problem? No. You want to spend 2 seconds estimating to make sure that you're in the neighborhood. Now, for tonight's homework, this homework is estimating. That's the homework. You are not supposed to give me the exact answer. In fact, if the question says to estimate, and you gave me the exact answer, if the exact answer is 17.8, and that's the answer you gave me, I'm going to do what? I'm marking it wrong. I don't want the exact answer. What do I want here? I want an estimation. That's the point of this assignment, is for you to get good at and quick with estimating, not the exact answer. Today, I don't want the exact answer. For each one of these, it says estimate using front-end estimation, estimate by rounding, estimate by using clustering. Here's my deal. You know the instructions on here that says, estimate by rounding, estimate by using front-end estimation, estimate by clustering? I don't care at all. I could not care any less what method you use. I don't care. I want you to estimate, which means that nobody should be giving me any decimals as an answer, because an estimate does not have a decimal. Does that make sense? Question.
So when it says that you can just use like any when you.
And it says use front end, you use whatever. You estimate in whatever way you like. That's the deal. Okay? For real. And this today is all adding and subtracting, right? This is all estimating, adding, and subtracting. So my suggestion to you would be to, what about this? What if I have 4.74 plus 87.92? Here's the deal. Notice on this one, you can use whatever method you want. But notice this. This 4.74, what are you probably going to make that?
5.
Could you make it 4? Could you make that 4? Yeah. Sure. What do I care, right? What's the difference? The difference between 4 and 5 is whatever you want. Okay, let's just say I'm going to round. In other words, in this one, to make that 5, what have I done? I have rounded, right? In this one, I rounded and made it a 5. In fact, on this one, I rounded to the nearest whole, right? The nearest one. In this one, do you know what would I do? What would you do? You know what I would do? I would make 87.92. I'd make it 90. I'd make it 90. Could you make it 88? Yeah. Sure. You could make it 88. But you could make it 90. It would not be a problem. Right? 90 plus 5 is 95. If you make it 88, you might have a little math to do, right? And so all of a sudden, do you really, remember, how long should this take you?
2 seconds.
2 seconds, and you want to make this as simple as possible, right? So whether you did 4 plus 88, or 5 plus 88, or 5 plus 90, or 4 plus 90, whatever, just you notice on this one I rounded the nearest ones, here I rounded the nearest tens, whatever. There's no right or wrong here. I want you to do it so that it happens quick. It's accurate, but it's quick. Whatever is quick. That's all I care about. Okay? Make sense? All right. Let me give you your homework.
You never want us to
When we're estimating, I don't want decimals. If you're using decimals, then you're not estimating, right? Technically, if you do this correctly, how long should this assignment take you? Like 5 minutes. Because it takes time to write things, right? But how long should each problem take you? 2 seconds, right? So it shouldn't take you long, because I just want a nice round ballpark figure. If you're in the neighborhood, you get it right. Tomorrow, when they're going to give the answer, and they're going to say the answer is, estimated is 25. I'm going to say, as long as your answer is between 20 and 30, you're in good shape. You know what I'm saying?
Wow. 20 and
Between 20 and 30.
30? Oh my God.
That's what I'm going to do. I just want you to be able to look at this and go, yep, I got it. Yep, oop, I was close. I got it. I don't want this to take you a long time. If it takes you a long time, then you're not estimating. Right? Yeah. Okay. Let me tell you what your homework is. Today is the 15th? No, wow, 22nd. Wow. Okay. Right?
Page 130.
Yeah. Page 131 through 32 even. Let me just double check that is not too difficult. It is not. That is simple. The rounding portion might take you a smidge more time, because that's nothing to do with estimating, right? But it is have to do with estimating, but whatever. You got it.
Rounding, that's like what you do in stores when it's like something's 40, 45.99. You do